In today's lesson, we are going to be looking at expanding binomials. So this is going to be the second half of our quadratics unit. And we're going to be looking at kind of changing between different forms. Right? So expanding binomials is something that you might have seen in grade 10. You probably should have seen it in grade 10. We're going to basically be multiplying situations that look like this. Binomials, or a binomial, means two terms. So we're multiplying multiplying two terms by two terms, or a bracket that has two terms by another bracket that has two terms. And one of the methods that we can use to do this is the FOIL method. So this is one of the methods that you may have learned. Maybe it's called the FOIL or the rainbow method. You might have seen something like this. And what the FOIL method refers to, F represents first, O represents outside, I represents inside, L represents last. So really that's just it. What it's doing is it's telling us what we need to be multiplying. So if I look at this example here, following the FOIL method, F tells us to multiply the first two numbers. So the first number in each bracket. O tells us to multiply, I'll use a different color. O tells us to multiply the outside two numbers. So the 2x and the 9. I tells us to multiply the inside. So the two inside numbers. And then L tells us to multiply the last numbers of the brackets. So really it's just a designation to tell us what numbers we need to be multiplying. Now, this really only specifically works for binomials when we have two terms and two terms. But as long as you're understanding what the FOIL method is doing, that will be helpful if you're given multiple things. Right? And essentially what the FOIL method is telling you to do is multiply every term in the first bracket by every term in the second bracket. So the 2x is being multiplied to the 4x and the 9. The negative 7 is being multiplied to the 4x and the 9 as well. So let's go through and look at some examples. So we want to expand and simplify the following using the FOIL method. So I'm going to show what I'm going to multiply. Now I don't have to write FOIL every single time. If it helps you, but then by all means, you can go through and do that. So actually I'll go back and break it down step by step. So x times x. Again, depending on how comfortable you are with doing some of the math in your head, you might break it down step by step. So x times x is the first one. Plus x times 4 plus 5 times x plus 5 times 4. Now, you don't necessarily need to show this step. You could, if you know what you're multiplying, you can just write the product down. Right? So you could just kind of skip over that step where you write everything down. Now, if you don't remember or you need to see it visually, then definitely write down that first step. But x times x is x squared. X times 4 is just 4x. 5 times x is 5x. And 5 times 4 is 20. So now I've expanded. I've multiplied everything out. Now I need to simplify. I need to combine like terms. And if we go back to grade 9, like terms are terms that have the same variable and exponent. So the only like terms I have here are the 4x and the 5x. And I can combine those because think of it as 4 apples plus 5 apples. I have 9, or I have 9x, and then plus 20. So the x squared and the 20 can't be combined. They're not like terms. So in the end, x plus 5 times x plus 4 becomes x squared plus 9x plus 20. And we're just going to do that with some different examples. So again, with the next one, x times x is x squared. X times 6 is 6x. Negative 3 times x is negative 3x. And negative 3 times 6 is negative 18. So here I kind of skipped that beginning step and was doing just putting down the answers to the multiplication as I went. I can collect like terms. So the x squared stays the same. 6x minus 3x. So again, look at the sign in front. That will tell us what the operation is. So 6x minus 3x, or 6 minus 3, is positive 3x minus 18. And there is my expanded and simplified form. For C, exact same thing, just slightly different terms. 5x times 4x, so 5 times 4 is 20, x times x is x squared. 5x times negative 3, 5 times negative 3 is negative 15, and the x gets carried along. 2 times 4x, 2 times 4 is 8, and then the x, and then 2 times negative 3 is negative 6. I can collect like terms, my two middle values. So I ended up with 20x squared minus 7x, because negative 15 plus 8 is negative 7, and then minus 6. For D is a little bit more challenging because I have a single value outside of my two brackets. So if that's ever the case, what you can do is you can expand or you can multiply that term or that value outside of the brackets into the first bracket. So 2 times x gives me 2x. 2 times negative 1 is negative 2. Now that I've multiplied that 2 into the first bracket, now I can use the FOIL method, or I can expand these two binomials. So 2x times x, we get 2x squared. 2x times 4, we get 8x. Negative 2 times x is negative 2x. And negative 2 times 4 is negative 8. Looking for the like terms, it's only 8x and negative 2x. So 2x squared plus 6x minus 8 is my simplified or expanded and simplified form. E and F look a little bit challenging because they look different, right? But we have to remember, what does an exponent mean? So that exponent of 2 is really just a fancy way of saying x minus 3 times itself, or x minus 3 times x minus 3. So it's just a different way of writing those two brackets because they are exactly the same. So once I rewrite it, I can expand, or I can use my FOIL method and expand. X times x is x squared. X times negative 3 is negative 3x. Negative 3 times x is negative 3x. And negative 3 times negative 3 is positive 9. Again, with my like terms, the two terms in the middle, x squared minus 6x plus 9. And F is the exact same thing, or not exact same thing, but same idea. The squared, or the exponent in the one bracket, is really telling me that I have the same bracket twice. So 9x times 9x is 81x squared. 9x times negative 2 is negative 18x. Negative 2 times 9x is negative 18x. And negative 2 times negative 2 is positive 4. Again, my two like terms are going to be the ones in the middle. 81x squared minus 36x plus 4. And that is my expanded and simplified form. So that's using the FOIL method. That's probably the most common method to expanding binomials. There is another method, and that's called using a box method, right? So the way the box method works is you're going to place the terms of one bracket on the top, the other on the side, and you're going to multiply each corresponding row and column, similar to that of a multiplication table. You're then going to simplify and collect your like terms. Right, now one thing to note, this only works with 2 brackets. Right, so if we have a situation where we have a number out front or 3 brackets, you might need to simplify first before you can do or use this method. So if I look at the first one, x plus 3, the x plus 3, I'm going to put the terms on one side. So I'm going to put x here and positive 3 here. I'm going to put x plus 5 on the top. It doesn't really matter where they go. And now I'm going to treat it like a times table. So x times x, we get x squared. X times 5, we get 5x. 3 times x is 3x. 3 times 5 is 15. So those are all my individual terms, but I do need to collect my like terms. And generally, if we have lined it up correctly or put things in the right spots, our 2 like terms should be the diagonal. So we have x squared plus my 2 like terms, which is 8x plus 15. So either way is fine. It depends on what you prefer. Right, so x minus 5, so I have x and minus 5. I put that on one side. I put the other one, 6x and 12 on the other side. And now I just multiply the row and the column like we would a multiplication table. So x times 6x, 6x squared. X times 12 is 12x. Negative 5 times 6x is negative 30x. And negative 5 times 12 is negative 60. Again, the like terms are on the diagonal. So I write out my 2 other terms. So 6x squared and have minus 60 at the end. And the middle term is going to be negative 30x plus 12, which would be negative 18x. So I get 6x squared minus 18x minus 60. I can do it for examples where we have the exponent, because I can just rewrite this as 5x plus 4 times 5x plus 4. So I'm going to put each bracket 5x and 4, 5x and 4, and I have it set up now. So 5x times 5x is 25x squared. 5x times 4 is 20x. 4 times 5x is 20x. And 4 times 4 is 16. Collect our like terms. We end up with 25x squared plus 40x plus 16. So again, whichever method you prefer is fine. The FOIL method or the more algebraic method, that is helpful because that method will allow you to multiply any type of bracket in terms, whereas the box method, you could do it with other terms, but you will have to incorporate maybe more columns or rows, whereas it really only works nicely if you just have 2 binomials. Lastly, with expanding binomials, we can apply this sometimes to area questions. So if I wanted to write a simplified expression for the area of the shape below, which is a rectangle, I need to think about what my area formula is. Well, the area of a rectangle is length times width. And now here I don't have actual numbers for the length and the width, but I do have representations. So instead of length, we could say it's x plus 6. And instead of width, we can say it's x plus 3. Now, if I want to write a simplified expression for the area, I can expand this using the FOIL method or the box method if you prefer. X times 3 is 3x, x times x first is x squared. X times 3 is 3x. 6 times x is 6x. And 6 times 3 is 18. Again, collecting my like terms, and I end up with x squared plus 9x plus 18. And and that is my simplified expression for the area of this shape. Right. So hopefully this was review, but we were basically looking at expanding binomials, multiplying two terms by two terms in brackets. We looked at the FOIL method, which is most likely how you've learned this in the past. We've also looked at the box method, which is another viable method if you find this more helpful in terms of organizing and in terms of understanding what to multiply. And then we looked at kind of just how we can kind of have some area questions that use this concept. So even if it is a review from last year, just make sure you are comfortable with multiplying two binomials. It is something you are going to have to do when we move further on with our quadratics unit.